Chapter 4, Strong Acid, Strong Base, Class Life Science. Part 7, Titration, Strong Acid, Strong Base. At the end of this session, students should be able to master the pH metric study of the reaction between a strong acid and a strong base, perform the pH metric titration of strong acid, strong base. Part 6, Effect of dilution. Dilution, that means the volume of distilled water added to immerse the electrode of pH meter. What is the effect of this addition? During pH metric titration, we add distilled water into the beaker to immerse the electrode of pH meter. Does this addition affect the result of the titration? We will see that. First, the effect on pHi, on the initial pH. We have two cases. If the acid is placed in the beaker, after addition of distilled water, which is dilution, then the concentration of the acid decreases, and therefore the concentration of HCO plus decreases. Then the initial pH decreases. Why? Because pH equal negative log concentration of H3O plus. Then concentration HCO plus and pH are inversely proportional. When concentration of H3O plus decreases by dilution, then pH increases. Then the addition of distilled water increases the pH at initial pH. B, if the base is placed in the beaker, the same after addition of distilled water, dilution, the concentration of the base decreases, then the concentration of HO minus decreases, therefore the initial pH decreases. Why? Because in basic solutions, strong basic solution, pH equal 14 plus log concentration HO minus. When concentration of HO minus decreases, the pH decreases. Here, concentration HO minus and pH are directly proportional. When concentration of HO minus decreases, then the pH increases. Therefore, pHi decreases. The most important is the effect on the result of titration. Does the addition of distilled water to immerse the electrode of pH meter change the result of titration? We will see. After the addition of distilled water, which is diluted, the number of moles of H3O plus ions remains the same. By dilution, number of moles of solute remains the same. And since at equivalence number of moles of H3O plus introduced equal number of moles of HO minus, since number of moles of HO plus remains the same, then number of moles of HO minus added remains the same. Added at equivalence remains the same. And since CB is the same, we did not change the basic solution, same basic solution, then same CB. Therefore, the number of moles of HO minus, which is constant, equal CB times VBE. Since the CB is constant and number of moles is constant, therefore VBE remains the same. Therefore, the addition of distilled water will not change the result of titration. With addition of distilled water or without the addition of distilled water, volume of base added at equivalence remains the same. Conclusion: the addition of distilled water to immerse the electrode of pH meter does not affect the result of titration. Part 7, Shape of titration curve. First case, titration of strong acid by strong base, pH equal function of VB. The characteristic points are initial point VB equal 0 and pHi initial pH. Equivalence point of coordinates VBE and pHE all equal 7 at 27 degree, at 25 degree. And the maximum limit, which is the pH of the solution in the burette of the strong base 14 plus log Cb. The shape of the curve is the initial point, the equivalence point, and the maximum limit. The curve is formed of three parts. First part, the pH increases slowly. The curve forms a flat line. Second part, pH increases rapidly and the curve forms a jump of pH. Third part, the pH increases slowly again and the curve forms another flat line and it tends to a maximum limit. It remains below the maximum limit, though it tells the final volume to be, which is the given. Now, shape of titration curve for the titration of a strong base by a strong acid pH equal function of Va. The characteristic points or remarkable points are initial point with of coordinates Va equals 0 pHi, initial pH, equivalence point VAE and pHe equals 7 at 25 degree, and here the minimum limit of pH equal minus log Ca, which is the pH of the strong acid solution in the burette. The shape of the curve is as follows. The curve is descending. It's formed of three parts. First part, the pH decreases slowly and the curve forms a flat line. Second part, the pH decreases rapidly and the curve presents an inflection point, which is the equivalence point E. Third part, the pH decreases slowly again and forms another flat line and tends to a minimum limit, which is the pH of the strong acid solution in the burette minus log Ca. Tell the final volume. Do not exceed the final volume. Part 8. pH of the solution during pH metric titration. First case of a strong acid titration of strong acid by strong base. This is the titration curve. First, at equivalence point, the volume of base added equal VBE. The number of mole of HO minus added equal number of mole HO plus introduced. And therefore the medium is neutral. That means pH equals 7. Then at equivalence point, pH equals 7. Before the equivalence point, the volume of base added is less than VBE, from 0 to VBE, less than VBE. In this case, number of mole of HO minus added is less than number of mole of HO plus introduced, and therefore HO plus is in excess, and the medium is acidic. Then the pH equal minus log concentration HO plus. Concentration HO plus equal number of mole of HCO plus left over total volume. Number of mole of HCO plus left equal initial number of mole of HCO plus minus number of mole of HCO plus reacted. Number of mole of HCO plus reacted equal number of mole of HO minus added, which is CBVB. The number of mole of HCO plus left equals CAVA minus CBVB. Our V total, we calculate concentration of HCO plus left minus log concentration HCO plus equal to pH. V total equal volume of acid plus volume of base added plus volume of water added to immerse the electrode of pH meter. Third part, when volume of base added is bigger than VBE after the equivalence, VB between VBE and tell final volume. In this case, number of mole of HO minus added is bigger than number of mole of HO plus introduced, and therefore HO minus is in excess, the medium is basic, then pH equal 14 plus log concentration HO minus. Concentration of HO minus equal number of mole of HO minus left upper B total. Number of mole of HO minus left equal number of mole initial number of mole of or number of mole of HO minus added minus number of mole reacted. Number of mole of HO minus reacted equal to CAVA. Then number of mole of added equals CBVB. Left equals CBVB minus CAVA. Over V total. This is concentration of HO minus. 14 plus log concentration HO minus equal to pH. Application 13. We carry out the pH metric titration of 20 ml of hydrochloric acid solution by sodium hydroxide solution of concentration Cb equal 10 negative 2 mole per liter. We add 50 ml of distilled water to the beaker in order to immerse the electrode of pH meter. The volume of base added at equals is VBE equal 20 milliliter. A. Write the net equation of the titration reaction. B. Determine the concentration of the hydrochloric acid solution. C. Determine the pH of the solution in the beaker when the volume of base added is 10 milliliter and 30 milliliter. Application 13. We have hydrochloric acid solution HCO plus Cl minus of concentration Ca unknown, Va equal 20 milliliter. We add water of V equal 50 milliliter to immerse the electrode of pH meter. Then we add the sodium hydroxide solution Na plus HO minus of concentration Cb equal 10 negative 2 mole per liter. V volume of base added equal 20 milliliter. Part A. Write the net equation of the titration reaction. H3O plus from strong acid, HO minus from strong base, we obtain 2H2O. B. Calculate or determine the concentration of the hydrochloric acid solution at equivalence. Number of mole of H3O plus introduced to beaker equal number of mole of HO minus added from the purity. We replace number of mole of HO plus by CAVA and number of mole of base HO minus by CBVBE. Then Ca equal CB VBE over VA. CB equal 10 negative 2 times VB equal VBE 20 over VA 20 equal 10 negative 2 mole per liter. C. We need to calculate the pH of the solution after addition of 10 milliliter of sodium hydroxide. Then the composition is we have hydrochloric acid solution of Ca determined equal to 10 negative 2 mole per liter, Va equal 20 milliliter. We add water, distilled water of V equal 50 milliliter, and now we add sodium hydroxide of Cb equal 10 negative 2 mole per liter. We added a volume Vb equal 10 milliliter. The total volume here is 20 plus 50, 70 plus 10, 80 milliliter. The equation of the reaction is H3O plus plus HO minus give 2H2O. We added a number of mole of H2O plus equal to CaVa, and we added a number of mole of HO minus equal CbVb. At equivalence, number of mole HO plus equal number of mole HO minus. Before the equivalence, since Vb less than Vbe, then before the equivalence, number of mole of HO minus added less than number of mole of HO plus introduced. Before, for Vb less than Vbe, then number of mole of HO minus added less than number of mole of H3O plus introduced, and therefore HO minus is the limiting reactant. At the moment of addition of 10 milliliter of Na plus HO minus sodium hydroxide solution, it remains 0 mole for HO minus since it is the limiting reactant. H3O plus is in excess, it remains number of mole and of H3O plus minus number of mole reactant, which is equal to CbVb. Then CaVa, number of mole of HO plus added, minus number of mole reacted. Number of mole reacted equal number of mole of base added CbVb. Then number of mole HO plus left equals CaVa minus CbVb. This is the number of mole of H3O plus left. We calculate concentration of H3O plus left equal number of mole of H3O plus over V total equal CaVa minus CbVb over V total. CaVa equal 10 negative 2 times 20 minus CbVb 10 negative 2 times 10 volume 10 over V total 80 equal 10 times 10 negative 2 over 80, 10 negative 2 over 8, 1.25 10 negative 3 mole per liter. This is the concentration of HO plus left after the addition of 10 milliliter of sodium hydroxide solution. pH equal minus log concentration H3O plus equal minus log 1.25 10 negative 3. Equal 2.9. Second case for Vb equal 30 milliliter. In this case, we have HO plus plus Cl minus of Ca equal to 10 negative 2 mole per liter. Va equal 20 milliliter. We add water of V equal 50 milliliter to immerse the electrode of pH mixture. Now the volume of sodium hydroxide solution added of Cb equal 10 negative 2 mole per liter. We added 30 milliliter of sodium hydroxide. Vb added bigger than Vbe, then HO minus is in excess. The medium is basic. The equation H3O plus plus HO minus give 2H2O. We added CaVa of strong acid and CbVb of strong base. At the moment the HO minus is the excess, then HO plus is the limiting. At the moment of addition of 30 milliliter of sodium hydroxide solution. Then it remains the excess of HO minus equal number of mole initial added minus number of mole reacted. Number of mole reacted equal to CAVA equal to number of mole HO plus. Then it remains CBVB minus CAVA. This is the number of mole of HO minus left. We calculate the concentration of HO minus left equal number of mole of HO minus left over V total equal CBVB minus CAVA over V total. CB equal 10 negative 2 times VB equal 30 minus CA 10 negative 2 VA equal 20 over V total here equal 20 of HCl, 30 of NaOH, 50 and 50 milliliter, that means 100 milliliter V total equal 10 over 100 equal 110 negative 3 mole per liter. pH equal 14 plus log concentration HO minus equal 14 plus log 110 negative 3 equal 11. Then after addition 30 milliliter of distilled water, the pH of the solution equal 11. This is the end of application 13. Now, case of titration of strong base by strong acid. This is the curve of titration of strong base by strong acid. At equivalence, the volume of acid added VA equal volume VAE and number of mole of HO minus introduced equal number of mole of H2O plus added, and therefore pH equals 7, we have neutral medium. But before the equivalence, the volume of added is less than VAE, then number of mole of HO plus added less than number of mole HO minus introduced to the beaker, and therefore HO minus remains in excess before the equivalent, and the medium is basic. The medium is basic, that means pH equal 14 plus log concentration of HO minus. Concentration of HO minus before the equivalence equal number of mole of HO minus left over V total. Number of mole HO minus left equal number of mole of HO minus added minus number of mole of H3O plus added. Number of mole of HO minus introduced equals CBVB. Number of mole of HO minus reacted equal number of mole of HO plus added, which is CAVA. Then number of mole of HO minus left equals CBVB minus CAVA over V total. After the equivalence, the volume of acid added bigger than VAE, then HO plus remains in solution without reaction, and the medium is acidic. HO plus added bigger than HO minus introduced, and therefore the medium is acidic. HO plus is in excess. Then pH equal minus log concentration HO plus. Concentration of HO plus equal number of mole of HO plus left over V total. Number of mole of HO plus left equal number of mole of H2O plus added minus number of mole of HO minus introduced. Number of mole HO plus added equals CAVA. Number of mole of HO minus introduced equals CBVB. Then number of mole of H2O plus left equals CAVA minus CBVB over V total, this concentration of HO plus left. Application 14, we carry out a pH metric titration of 20 milliliters of sodium hydroxide solution by a hydrochloric acid solution of concentration Ca equal 10 negative 2 mole per liter. We add 50 milliliters of distilled water to the beaker in order to immerse the electrode of pH meter. The volume of base added at equipment is VBE equal 20 milliliter by, and by calculation we find that CB equals 10 negative 2 mole per liter. Determine the pH of the solution in the beaker when the volume of acid added is 10 milliliter, second case 30. Application 14. First case we have a sodium hydroxide solution of concentration CB equal 10 negative 2 mole per liter. VB add introduced equal 20 milliliter. We add water to immerse the electrode of pH meter of V equals 50 milliliter, and we add, in first case, HCO plus Cl minus hydrochloric acid of Ca equal 10 negative 2 mole per liter of of Va now added equals 10 milliliter. First case, when we add 10 milliliter of acid. In this case, VAE equal 20 milliliter. Then VA added less than VAE, then the medium remains basic, HO minus is in excess. The equation of the reaction HO minus plus H3O plus give 2H2O. We added a number of mole introduced in the beaker of base CB equal VB, number of mole of HO minus introduced. We added number of mole of acid HO plus CaVA. At the moment of addition of 10 milliliter of hydrochloric acid solution, the HO plus added is the limiting reactant, it remains nothing. The number of mole of HO minus left equal number of mole introduced CbVb minus number of mole reacted. Number of mole reacted equal to number of mole HO plus added, well, that means CaVa. This is number of mole HO minus left. We calculate concentration of HO minus left equal number of mole HO minus left over V total. V total equal 20 plus 50, 70 plus 10, 80 equal CbVb minus CaVa over V total. Cb equal 10 negative 2, Vb equal 20 minus Ca 10 negative 2, Va 10 over V total 80 equal 1.25 10 negative 3 mole per liter. pH equal 14 plus log concentration HO minus equal 14 plus log 1.25 10 negative 3 equal 11.1. Now second case, when VA added equals 30 milliliter. In this case, V total equal 20 from sodium hydroxide, 30 from hydrochloric acid, and 50 for distilled water equal 100 milliliter. In this case, VA added bigger than VAE, then the medium is acidic, H3O plus is in excess. Then the equation of the reaction HO minus plus H3O plus give 2H2O. We added CbVb number of mole of HO minus and CaVa number of mole of HO plus. In this case, the HO minus is the limiting reactant. Then at the moment of addition of the acid of 30 milliliter of hydrochloric acid solution. The number of mole of HO minus left equals 0 has disappeared completely after equivalence. At equivalence disappeared completely. After equivalence, the HO plus added left in the solution. The number of mole of HO plus left after addition of 30 milliliter equal number of mole added of HO plus, which is CaVa, minus number of mole reacted. Number of mole reacted equal to number of mole of HO minus present. That means CbVb. Therefore, concentration of H3O plus left equal number of mole of H3O plus left over V total equals CaVa minus CbVb over V total equals Ca 10 negative 2 times Va 30 minus Cb 10 negative 2 Vb equal 20. That means 10 times negative 2 over 100 equal 10 negative 3 mole per liter. And therefore pH equal minus or negative log concentration H3O plus equal negative log concentration, which is 10 negative 3 equal 3. This is the pH after the addition of 30 milliliter of hydrochloric acid. This is the end of application 14, and this is the end of part 9, titration strong acid strong base, and the end of chapter 4.